We want to find the Taylor polynomial of degree 3 centered at c equals 4 for the function f of x equals the square root of the quantity x plus 3. So we're trying to find a polynomial that would be a good representation of our function f of x around x equals 4. And the polynomial we'll find is called the Taylor polynomial centered at c equals 4. It's defined as we see here below, where in order to find the degree 3 Taylor polynomial centered at c, we'll have to find up to the third derivative of the given function and evaluate those functions at x equals 4. So beginning with our function f of x equals the square root of the quantity x plus 1, let's write this as the quantity x plus 1 raised to the power of 1/2. In this form we can find our derivatives. So f prime of x will be equal to 1/2 times the quantity x plus 1 raised to the power of 1/2 minus 1, that's negative 1/2. And normally we would apply the chain rule, but notice here the derivative of the inner function x plus 1 would just be 1. So that would be our first derivative. And now for the second derivative, this will be the derivative of the first derivative. So we'll multiply by 1/2, that's negative 1/4. We'd have times the quantity x plus 1 raised to the negative 1/2 minus 1, that's negative 3/2. And then the third derivative is equal to the derivative of the second derivative, so we'd multiply by negative 3/2, that'd be positive 3/8, times the quantity x plus 1 to the power of negative 3/2 minus 1, or negative 5/2. And now we'll evaluate each of these functions at 4. So f of 4 would be equal to 4 plus 1, or 5, raised to the power of 1/2. Now let's write the remaining of these function values using positive exponents. So we'll use the exponent rule, x raised to the power of negative n equals 1 divided by x to the nth. So for f prime of 4, we'd have the 1/2, but then here we'd have 4 plus 1, or 5 to the negative 1/2, which is the same as 5 to the positive 1/2 in the denominator. And then for f double prime of 4, we'd have negative 1 over 4. This would be 5 to the power of positive 3/2 in the denominator. And then finally, f triple prime of 4 is equal to 3 divided by 8, and then we'd have 5 to the positive 5/2 in the denominator. Now we can find our Taylor polynomial centered at c equals 4 using this definition here. Let's do this on the next slide. The degree 3 Taylor polynomial for the given function will be equal to, the first term is f of 4, which is 5 to the 1/2, plus f prime of 4, which would be 1 over 2, 5 to the 1/2, times x minus c, which in our case would be x minus 4. The next term is going to be plus f double prime of 4 divided by 2 factorial times the quantity x minus 4 squared. So because our derivative function value is negative, we'll have minus 1 over 4 times 5 to the 3/2. Now we do have a 2 factorial here in the denominator, so we'll go ahead and put this here, times 2 factorial. And then we have times the quantity x minus 4 squared. And the last term for our Taylor polynomial will be plus f triple prime of 4 divided by 3 factorial times the quantity x minus 4 to the third. So again, we'd have 3 divided by 8, 5 to the 5/2 times 3 factorial in the denominator times the quantity x minus 4 to the third. And now let's go ahead and simplify this. First term is 5 to the 1/2. We could write that as a square root of 5, but let's just use rational exponents. So we have 5 to the 1/2 plus, because the numerator is just 1, we can write this as the quantity x minus 4 divided by 2 times 5 to the 1/2. The next term is negative, so we'll have minus, the numerator is 1, so let's go ahead and write the numerator as the quantity x minus 4 to the second. Now our denominator, 2 factorial is 2, 4 times 2 is 8, so we'd have 8 times 5 to the power of 3/2 in the denominator. And then for our last term, we have plus, let's take a close look at this fraction here. We have 3 all over 8, 5 to the power of 5/2, and then 3 factorial is 3 times 2 times 1. Notice how the 3's simplify to 1, so we have 1 over 16 times 5 to the 5/2, and since the denominator is 1, we can write the numerator as the quantity x minus 4 to the third, and then we have 16 times 5 to the power of 5/2. So this would be the third degree Taylor polynomial for the given function f of x equals the square root of the quantity x plus 1 centered at 4. Let's compare the graph of our Taylor polynomial to the graph of our function around x equals 4. The original function is graphed in blue, and the Taylor polynomial is graphed in red. Keep in mind the Taylor polynomial is centered at x equals 4, which is here. And notice around x equals 4, the red polynomial is a very good representation of the original function f of x, which means if we needed to, we could use the polynomial function values as approximations for the true function values of f of x. I hope you found this helpful.